Case study, descriptive statistics. In this case study, you have a factory that dispatches spares of its products to 5 dealers each day. Quantities requested by a dealer are received and delivered on the same day. The table you see on your screen depicts the daily dispatches that each dealer gets in a span of 6 days. You also have the total dispatches by the factory. You are required to determine the extent to which the requirements vary at the dealer level and subsequently affect the production at the factory level. Determine your findings and z-values for both the maximum and minimum values at the dealer and factory level, because this z-value will help you plan your production at the factory. Let's look at the solution. Let's calculate the mean, standard deviation, and coefficient of variation for dealer 1. For values x1, x2, x3, x4, x5, and x6 with mean x bar, the standard deviation is the square root of 1 by 6, summation of xj minus x bar whole square, where the summation ranges from j equals 1 to j equals 6. Hence, the mean for dealer 1 equals 1 by 6, multiplied by 83 plus 67 plus 85 plus 74 plus 62 plus 82, which is 453 by 6, which is 75.5. Note, if there are n values, 6 will be replaced by n. The summation ranges from 1 to x. For standard deviation, let's calculate mean, then for each number, subtract the mean and square the result. Then work out the mean of those squared differences. Take the square root for the arrived number. The coefficient of variation for dealer 1 is calculated as per the formula. Standard deviation by mean, multiplied by 100, it becomes 8.61684 by 75.5, multiplied by 100, which comes to 11.413. The solution to determine the degree variations is to find the coefficient of variations for both the dealers and the factory. After calculating the coefficient of variation for all dealers and the factory, the values indicate that variation at the factory level is less compared to the variations at the dealer's level. You can see that the variation is relatively higher for the first dealer as compared to the others. In general, high values of coefficient of variation indicate that the level of uncertainty in demand is high. In such cases, the dealer or factory could run the risk of shortages or surplus stocks. When the value of coefficient of variation is low, such risks are less. In this example, the levels of uncertainty for both the factory and dealers, and consequently the risk, are quite low. Further, the level of uncertainty is lower for the factory than for the dealers. The table you see on your screen lists the maximum and minimum values. Then, we calculate the corresponding z-values using the known formulas. Let us better understand how these values are obtained. The column max in the table indicates the maximum of the 6 values for a dealer, and column min indicates the minimum value. Dealer 1 has values 83, 67, 85, 74, 62, and 82. Here the maximum value is 85 and minimum is 62. Similarly, the max and min values for other dealers are also obtained. Next is the z-score. Z-score for a value equals value minus mean by standard deviation. Hence for the max value 85, the first dealer, Z-max equals 85 minus 75.5 by 8.61684 is equal to 1.10249. Similarly, other z-values can be computed. As discussed in theory, the standard score or z-score of a value in a data set, briefly stated as z-value, in the number of standard deviations by which that value is above or below its arithmetic mean. A z-value of 2, for example, indicates that the value in the data set exceeds the arithmetic mean by 2 times the standard deviation. Usually, in many business situations, about 65% of the data have z-scores between -1 and +1. About 95% of the data have z-scores between -2 and +2. About 99.7% of the data have z-scores between -3 and +3. In this specific example, however, owing to low levels of variations, as observed from the coefficient of variation, we can see that the z-scores or the standard scores vary over a narrow range, which shows that the levels of uncertainty, both for the factory and the dealers, and consequently the risk, are quite low. Further, the level of uncertainty is lower for the factory than that for dealers, which means higher the z-score value, higher the risk of production getting affected at the factory. Lower the z-score and lower the risk of the production. This enables factor to choose the best dealer for the goods that can be dispatched on regular basis.